All right, so we're here to talk about open source and why it's awesome and how to secure it. And I am Nicole Schwartz, Circuit Swan. I use she, her pronouns, and I'm a senior security product manager at ActiveState. And in 1 month, I'm running BSides Edmonton. You could come visit us. It's not that bad of a drive. And what is ActiveState? We help you secure your open source. So feel free to check us out. But this is not an ad, so let's actually get to the content. All right, what is open source? It's code that you can look at, you can modify, you can enhance, and that's really what it boils down to. It's way more complex than that, but when you go around and you look at things that are like, oh, hey, this repo, it's available under the MIT license or the BSD license, that is generally an open source thing that you could use yourself, depending on the licensing, and you could modify it if you want to. You contribute to their copy if you want to, you know, all sorts of options. Why do we care? Well, nowadays, you know that constantly, every time you log into a SaaS product, things change, right? And you're like, oh, why did that move there? You know, oh, there's a new feature over here. Isn't that cool? The reason we have such rapid development of software and such rapid innovation is because nobody has to reinvent the wheel anymore. No one has to necessarily be an expert in cryptography anymore. Please don't write your own cryptography. Thank you. There are people who are domain-specific experts. Maybe use that. And this is all free. So you can leverage these tools that are not the thing that you're trying to differentiate on to get something to market quickly. That's amazing, that's awesome, that is what has brought us here. But all those upsides do come with some downsides. Now, interestingly enough, when I think it was Synopsys, I can't read the teeny little thing there, but I think it's Synopsys reviewed a whole bunch of code, and they found 77% or more of the code that they were reviewing was open source, meaning that only 30% of the code was bespoke written and making the differentiation of what is this cool thing that I'm selling you or offering you, you know, a license to. And so if you think about everything that you're using on an IoT device, as a software application, in your car, it's reliant on open source, which is kind of awesome. And that comes with a catch. Your lawyers will tell you there's a license with that. Now, not every open source package includes a license. That's a whole different thing we are not going to get into here. But if it does include a license, there's going to be specific rules there. If you use that, maybe you have to make your source available. And if this is like got some business logic in there or business secrets in there, you may not want that. And those are generally called copyleft licenses. So your lawyers may be like, please don't use a copyleft license in these software packages here. But hey, in these other packages where we don't have anything like super crazy custom that, you know, somebody can't ask to review that code, go ahead and use it. There's defects and vulnerabilities. You can't tell me that the code that you write doesn't have defects and vulnerabilities. So you're expecting the code that the internet writes with a whole bunch of, you know, squirrels, ADHD out there is gonna have no defects? Defects are everywhere, you can't get away from it. Now, one of the theories was like, hey, with all these people looking at open source, we're gonna find the vulnerabilities. Well, if you look at the number of known vulnerabilities versus the number of open source packages out there, we do not know about all the vulnerabilities out there. So if people look, they find them, but people don't always necessarily look. So it's gonna be vulnerabilities you know and vulnerabilities you don't know. Also, supply chain threats. We'll kind of get into this in a little more detail, but everything you introduce, as referenced earlier by TJ, introduce surface area. And so the more surface area you have, the more risk you have. And also, what happens if the community abandons that project? What are you gonna do? All right, so let's dig into these in a little bit more detail. So hiding among all of these awesome Lego pieces, which are the open source, one of them has a copy left. Oops. Do you know which one that is and that you could remove that and replace it with something else? That is, you know, a risk. Like, are you aware what all these little Legos are? You need to find the one little tiny, you know, tiger in here. It's like a Where's Waldo adventure. All right, we've all seen this before. XKCD. Please don't invent your own license. There's enough license choices out there. So like the list of available licenses is very, very long, and then people keep adding more. So make my life easier. Make lawyers' lives easier. No more licenses, please and thank you. Anyway. All right, so the defects and vulnerabilities, we talked about this. There's going to be ones that are accidental, heartbleed. Maybe don't drink and contribute open source code on New Year's Eve. Not a great plan. But there's also intentional, and this was referenced earlier, the XZ utils, which was low, slow, really patient, we're really lucky it got caught situation. And of course, there's just like the super, wild and crazy, I'm going to introduce this malware in here to see if it gets caught, that some researchers do. Please don't introduce it into packages if you're a researcher. Like, do a different package just to see if it works. Anyway, so turtles all the way down. Your code uses open source. The open source uses open source. That open source uses open source. If you've heard the word dependency tree, this is what this is referencing. So that dependency tree means that all those things all the way down are technically your risk surface area. But this morning we did also hear about like threat modeling. If it's not reachable, so a lot of SCAT tools talk about, our software composition analysis tools talk about reachability. If it's a couple layers down and it's not being called by anything, or it was only used in the build process, it's probably not something you need to worry about. So you really do need to like, okay, yes, this is my surface area, but how much of that do I care about? All right, so I keep blathering on, supply chain, supply chain. What am I talking about? If you've ever done code, you probably know this, but we're just going to go through it. And my slides will be available on circuitswan.com later, so all the teeny tiny things you can read there. But you've got the source that you're writing. You're bringing in some open source, you're bringing in some other suppliers that you've made deals with, you're writing your own stuff, you're stitching that together into a build, the build becomes artifacts, the artifacts go out somewhere. Maybe that's a wheel on PyPy, or maybe it's SAS, or maybe it's an XE that your customers download. At every point along here, you can have risks. Now, you did this, but also every single one of the open source things that you use, those wheels, also did this and had those same risks. And like was talked about earlier, do you know how they're practicing? Are they doing two-person review? Are they doing it on like the YOLO laptop that maybe also surfs, sketchy websites that have pirated material, whatever? Like, you don't know. So you're not going to be able to get a security audit from an open source project. I mean, maybe you could in some circumstances, but in a lot of cases, those are volunteers, and they may not have the time or the expertise to give you that kind of information. So that is something you're going to have to either accept or maybe mitigate in some way. All right, again, the slide's super tiny, apologize. It's the SAP Supply Chain Risk Explorer. You look at it on a bigger screen. And it goes through a bunch of things like typo squatting, which hopefully you all know is like where I misspell things all the time. Hopefully it's not just me, but popular packages, they might just flip two of the letters or substitute one of the letters. And so you can do everything right, but pull down a package that is a typo squatted version, which is a copy of that code perhaps, but with a little malware sprinkled in. There's also things where they might just compromise the build environment. SolarWinds is the one we pick on for that. I feel kind of bad for them because they always get picked on for that. But there are tons of different risks with fancy names, but they all boil down to that chart earlier where all those different risk pieces were. Fancy words for all the different points in there. All right, so also, these are volunteers. And it's free like puppies, not free like beer. And so these need to be taken care of once they come into existence. Otherwise, they might pee on your carpet or something. And so if the community kind of doesn't keep up with it, or maybe just straight out abandons it, or nobody's really interested in it anymore, you're stuck with it now if you're using it and you're reliant on it. So what is your backup plan? Are you going to fork that and maintain it yourself? That is absolutely a choice you can make. Depending, that may not be a very fun choice. All right, and everyone was expecting this, right? Yeah. So the one poor little project that one person's been maintaining, you could just burn out. If you're the only one and everybody else is just relying on it but not helping you, you may just be like, I'm done. All right, cool. So we talked about open source is awesome. It has enabled us to have all of the cool, fast development that we have today. but it does increase our surface area risk. So how do I tell what I'm using? So shout out again to the earlier talks, is the unsexy thing of inventory management. So as part of that inventory management, not just what container do I have, what open source is running on that container? Not just what projects do I have, what open source is in those projects. So when we talk about inventory, it's not just how many laptops are hanging out. You really have to get pretty granular with this, and that allows you to respond to issues. If I were to come to you and say, hey, I just read a news article this morning that this package has a vulnerability. Do we have this package in our environment? If you don't have an inventory, how are you going to answer that? You're probably going to have to go around and ask everyone. You're going to have to spend a lot of time looking for that. But if you've got an inventory, I don't care if the inventory is in like a Google sheet or an Excel sheet, you could look through and be like, hey, it looks like we currently don't have that. So I think we're okay. It's going to be a lot better of a conversation than like, hey, let me go ask everybody and get back to you. All right. So how do you get that inventory? Because saying have an inventory is pretty, like just do this, which is never a just. So you could have your own repository and ask everyone to go through that. So please don't go through NPM. We're going to go through our own copy of NPM where we're actually proxying it. So I kind of know what's in use. You could have that be restricted where until a package gets approved, maybe they can't pull it in, or you could have it be unrestricted so that anytime they want to pull something from pip or whatever, it'll pull it, but now you'll at least know what's being used. You could just scan the repositories. You could tell them that they need to request approval for every package they add, which apparently is what they do at Google, which shocks me and confuses me. There's like apparently a chat channel where every time you want to bring in a package, you have to like have a chit chat about it. I'd love to be a fly in the wall for that. And you could just ask each team to report in. This is where SBOMs, software bill of materials, which you've heard referenced, come in. And by the way, software bills of materials should be done all the time. There are plenty of open source tools out there that will help you build those, because to have an accurate picture of the build at any point in time, you need to know at that point in time what the build was. If you're not a developer and you haven't heard, well, it works on my machine, then you may not understand that because a lot of things have a range. So like that TensorFlow package or that Pandas package, the developer's going to say, hey, use any version between like 2.1 and 2.2, anyone in there. And so the solver is going to like go today, on Tuesday, I feel like 2.1.3, and oh, but tomorrow I feel like 2.1.4. And so you may not realize that like today's copy is not exactly the same as tomorrow's copy. So having that SBOM for every point in time is important if you want to have that accurate picture. And you could do some kind of combination of the above. All right, I want to do a shout out. TJ mentioned third party. This is not about your commercial things. So for your commercial stuff, you can say, hey, can you give me a security assessment? I don't think that's going to work out really well with open source. But for open source, in a lot of cases, you may actually be able to get a SASA, which attests how they did a build, and it may in the future attest other things. And you may be able to get an SBOM from them. And there's stuff like the PyPy Trusted Publisher, which if you publish through ActiveState or GitHub, you can get a little green check mark on your PyPy package, which means you at least signed your package and like had a trusted situation. So maybe it's not a man in the middle. We know thanks to SolarWinds, not everything's perfect, but at least it's another layer. All right. You have an inventory. You picked some combination of those things. You're either generating the SBOMs or you've got your mirrored repository, and you at least have a pretty good guess of what's going on in your environment. All right, so I just told you there was exponential risk for every single little piece of this chain. How do you mitigate it? Well, if you have a time machine, secure by design, or if you're starting a new project, secure by design. Security scanners, there's free ones out there. If you are aware of OWASP or the Open Source Software Foundation, they have really good lists of like, here are free open source packages which you can use. There's the OpenSSF scorecard, which you can run against a repository, and it'll kind of give you This is an oversimplification, I apologize, but it'll give you like a what good practices is this repo following. It's what they chose to audit and what they could audit as far as good practices go. You can read about that for a little bit more. There's SASA, trusted publishers, GWOC attestations. We'll get into more details about these in a minute. There's the repository thing I talked about, because not only if you're auditing those, you could then scan those. You could then, be doing checks against those using like Daggerboard or something. Having a vulnerability triage and remediation process. Don't just YOLO it. Have some kind of cadence every 2 weeks, every month, where you're like, let me check and see if there's any critical things, terrible things hiding in there that we don't want. And have some kind of target. Even if you don't like externally publish it, just have an internal target. Can we get rid of criticals in 90 days? Like set something, and then maybe you can walk it back. Okay, cool, we're hitting 90 days. Can we hit 80? And just give yourself a goal and maybe give yourself a pizza party if you hit it. Try and keep somewhat up to date. Bleeding edge isn't always great. A lot of you probably may not buy the brand new widget when it comes out day one, because you want somebody else to find the hiccups, right? And you want to see where the problems are. Same kind of idea. Maybe let some other people find the hiccups first, and but don't let yourself get further and further back, because the community tends to update, and you're gonna get into a situation where maybe you're a year and some old now. The choices of what will partner with those open source things that you're using kind of get stuck in the past, and you can't use, so you're gonna lose some of the advantage of open source. You can't use some of those cool new packages because they just don't support that. But also you're going to approach closer and closer end of life. And when you hit end of life, it's almost like hitting abandonment of the project, because they're like, we are not updating that anymore. So if somebody finds a vulnerability, good luck. So you don't want to be there. All right, and what outgoing calls are happening? There's a package that is escaping my mind right now. But think of it like a DAST scanner, but for packages that are running. Any kind of network thing can monitor for this. But do you usually have calls going out to China, to Russia, to North Korea? Are there suddenly calls going out there from your build environment? That's new, that's odd, and maybe you should look at what changed between when it wasn't and when it was. And so when I was working at GitLab, they actually would do this for a bunch of the popular packages that customers were using, which was you could have your package built and run and tested to see, was it making weird calls, weird unexpected calls, and then it'd flag it as like, hey, do you really want to use this dependency? Or if you do you really want to deploy it to production? Because that was maybe unexpected. Maybe you say, you know what, that is totally expected and wanted, cool, but at least look for it. No head in the sand, no ostrich. All right, so secure by design. I'm going to read my notes on this one because there's a lot of notes on this one. So CISA is advocating that people prioritize features, mechanisms, and implementation of tools to protect customers rather than prioritizing product features. If you work for a company, you're probably laughing inside your head right now. This would be great because it means more protection for your customers, but I really don't feel that this it, like, don't just YOLO it out to the internet, but maybe don't bother to work on it quite as much. So threat modeling is awesome. I don't care which methodology you use, but again, that was that whole concept of where are the crown jewels versus not. And then defense in depth, like, do not be like, we are going to have the perfect software composition analysis scanner, and we're not going to do anything else. It's like, all right, let's scan our open source, let's scan our own code, let's scan for secrets, let's do an assortment of things so that hopefully somewhere along the way we catch something and we don't completely miss it. Because kind of the talk right before mine, usually it's not just one thing. There's a preponderance of usually X happens and then Y happens and then Z happens. So even if you miss that first step, if you catch it at the second step, you still might be fine. All right. And security scanners, I'm going to go kind of into detail, but I listed at least one free example for each one of these. So we've got the GitHub code scanning for software composition analysis. We've got TruffleHog for secret detection. We've got SemGrep for SAST. We've got Trivy for containers. We've got Zap for dynamic application security testing. We've got Fussology for license scanning. And we've got OpenSSF package analysis for malware scanning. You can do it, little computer. All right, so SAST. This is kind of agnostic. Think of it as like Grammarly for your code. It's looking for certain patterns, and it's like, this is a pattern that we've identified to be problematic. Maybe don't do that. So it's not perfect, but it's better than, I think, just nothing. And it will kind of at least warn you in the IDE phase, maybe you need to make a different choice on here. All right, secret detection. How many times do you hear about somebody checking something in like an API key to their GitHub? Yeah, and that causes problems, right? And did everybody read the thing that came out at DEF CON where basically they're like, even if you delete it off GitHub, it actually is never, ever, ever deleted, so you have to rotate your keys? Yeah, so it is really important to look for, and I know it happens on accident, accidents happen, but make sure you have a plan to rotate your keys and scan for API things. And again, you should be, if you really want to protect a particular resource, do this on the open source code and your code. And then don't just tell the maintainer, like, YOLO, you did this. Maybe help them by submitting a patch. Anyway. All right, container scanning. This is, to me, just like SCA, but for containers. But they gave it a new name because we like to name everything. See the standards, XKCD from earlier. Anyway, it's going to find known CVEs in your container in the base image plus the open source that happens to be running on that particular one. All right, then we talked earlier about how like some people don't like the copy left, whatever. Fossology, other things will scan and be like, hey, here's all of the licenses you have. Which ones do you not like? And maybe your lawyer team will love you for this, and then maybe the developers will not love you for this. Stuff happens. All right, there's DAST. So we talked about SAST, which is kind of like the Grammarly thing. DAST is supposed to be a little smarter. It's supposed to have less false positives because it's actually poking the system. So the system's got to be running. So you can't run this like in the IDE. You've actually got to run it like in a test environment. So this one is actually super handy because remember we were talking about like, is that open source calling like a weird place or whatever? So if you've got like DAST plus a little bit of network monitoring in your QA environment or your staging environment or whatever, this is going to kind of give you a better picture of what is actually going on when the code's running. And so combine reachability with this, and you could probably just be like, I'm going to ignore all this stuff here because that was a runtime thing, that was an unreachable thing. Like this one's not actually being exploited because we monitor for SQL injection, so who cares? So hopefully that'll help you narrow it down to what you give a hoot about. All right, there's malware scanning, which is the open source software foundation package analysis tool. Again, it's looking for kind of like the MITRE framework. It's looking for like a behavior as opposed to just like a pattern. But it also does look for patterns. It's kind of like combining SAST and DAST together. All right, fuzzy lop. Has anybody used fuzzy lop in like a CTF? You can actually use it for other purposes. And this one's kind of fun because it'll find like your overflows and stuff. And memory leaks, which memory leaks in production can be very annoying as a person who used to work third shift and have to reboot a certain customer server at every morning at 2:15 a.m. Anyway, so please find your memory overloads. And if the tool that you're using, that open source, has a memory leak, maybe fix that so that you don't eat up so much memory and your cloud bill doesn't go up, whatever. And we've referenced SCA a lot here. It basically looks at what are the things, the components that you're bringing in, and what is out of date, what has a vulnerability, or at least like generates you a list. So this is very helpful in the list making capability. All right, so speaking of this, SBOMs and SCA are kind of like BFFs. Kind of sometimes an SCA uses an SBOM, or sometimes it'll make you an SBOM. If you work in Europe or the United States, SBOMs are becoming like a thing. So there are two formats of SBOM, Cyclone DX and SPDX, because once again, we can't agree on a standard. So OpenSSF Protobomb will convert between the two. So if you generate one, you can generate the other. So you can take the customers who are like, but I want the other one, and give them the other one and get them off your back. And then if you want to take those SBOMs and load them into Daggerboard, again, free tool, it'll tell you all the CVEs. So if you don't have an SCA tool, you can kind of use Daggerboard as your SCA tool, even though it's not an SCA tool. It's all turtles all the way down here. All right, and if you have not heard of the Vulnerability Exploitability Exchange, how many times do you have to say, this CVE doesn't affect us to some customer? A lot? Yeah? Okay, well there's a format for that. You can formally document this open source vulnerability, we've investigated it, and within our environment, because it's unreachable, because we are running this operating system and it affects that operating system, or because it's disputed by the maintainer, we say no. You can document that in this way and include it either as part of your SBOMs or as its own standalone thing and hand that out. And just be like, here's all the things you're about to complain at me about. Have this document. Come back after. All right, and we talked about the scorecard. And again, this, you pointed at a repo. All right, so we talked about what are you reliant on and what's really going to hurt you if it goes away. Figure out those packages you are super dependent on and consider running this against them, or say if somebody else has already run it and given you the scorecard, it's going to say like, hey, is there more than one maintainer? How active is this project? How responsive are they to bugs and things? And it'll kind of give you like a health/risk assessment. And so again, we talked about doing things kind of semi-frequently, not just one and done. So set a cadence, do this, and be like, are the thing that we are relying on, how risky is it? And do we need to have a backup plan? And your backup plan could be contributing to that open source project. All right, frameworks. I'm going to read the things because again, there's a lot of notes on this one. Supply chain levels for software artifacts was developed by Google and then released into the Open Source Software Foundation. And it is a set of standards or a framework that will help you prevent tampering and improve integrity of packages which are built. It gives you a shared language and shared understanding of what these levels mean. So if I say, hey, I'm SASA level 2 or SASA level 3, and that's how I build my stuff, that kind of lets you know, okay, this is ephemeral and it's isolated, and we don't allow somebody to just type in parameters. They are all documented, and I can reproduce this build. And so that's super handy just for having a conversation shorthand. Guac. Are developers really hungry when they name things? The graph for understanding artifact composition aims to fill the gap. So we talked about the dependency tree, and you've all seen them. They're like the sprawling things. This is trying to make it so that that's a little more useful. It's going to take in an SBOM and give you metadata about your dependency tree. So just like for funsies, load your SBOM in there just because it's interesting. But hopefully as it gets more and more metadata, that actually becomes more and more valuable to you. See, and then as far as attestations go, in toto seems to be the most popular one right now. There are other formats. You can invent your own format if you really want to. Maybe just consider in toto anyway. And attestation literally just means I documented this. Ideally, you also sign it. That's not perfect, but at least it adds like a little layer of nobody tampered with this. And then the PyPy Trusted Publisher, which I mentioned, allows you from like GitHub, GitLab, and ActiveState to say, I followed these build procedures and pushed using a key up to PyPy, and you get a little green check mark. So maybe check and see if the packages you're using have the nice little green check mark. All right, so I had said monitor repositories. What are your choices there? Well, you can use JFrog, GitLab, and ActiveState if you want to pay money. You can DIY it. Like literally you could just mirror them if you wanted to. And so there are a lot of options there. And for vuln triage and remediation. Anyone, we were talking about the 3-inch binders earlier today. Tune out the noise. Okay, how do I tune out the noise? In your SBOM or in your SCA, can you tell which things are runtime, which are 2 or 3 up the tree, which are reachable and not? Go ahead and just get rid of them first. Come back to them later if like you tuned it and then boom, everything's gone. A, I want to work for your company. And B, you can then move on to level 2. But for right now, those are the less risky things. So start with the things where it's first or second degree of Kevin Bacon away from your source code, and that is touching your critical stuff. Again, this is going to be based on your threat models. If this system is literally just like the static website, and somebody could deface it, yes, but then you could restore from backup, like, okay, whatever, versus the system that has people's information on it, versus the system that has people's like private health information on it or credit card information on it, like, which one are you going to do first? Let's do the credit card information. And then Okay, great, you found it all. What's your plan to fix it? Again, this is part of that, can we update? You don't have to go to bleeding edge. Sometimes actually to fix a problem, you go down. Because if you look in a vulnerability, it's gonna say it impacts this particular range. And that range may be pretty small. It may go back many, many years, but it may be small. And so you may be able to just roll back a couple and then you're okay. Please don't roll back like 2 years. And, you know, try to stay somewhat current, but I'm not gonna tell you to be bleeding edge. Like, that's a lot of work. But if you're working out that muscle and you're saying every 2 months, every month, we are doing a deployment and testing it, and I know that I can do a solve for all the open source that I'm using, and I feel confident that I could release this and test it, you're gonna be in a lot better place when I come to you tomorrow and I'm like, hey, that super package that we're using across everything in the company, major vulnerability going back 3 years, we need to update now. You're gonna be a lot less stressed because you're gonna be like, that's cool, we do this every month, we can totally get this done in like a couple days. This isn't gonna be earth-shattering. Whereas if you only release once a year, it's gonna be a little more stressful. So just get that muscle memory going. And again, have some kind of target, attach a pizza party, or if people don't like pizza, something else, maybe like an ice cream party, I don't know. And like you hit the target, everybody celebrate. And then you can bring down the target. And we just went through this, blah, blah, blah. I got ahead of myself. All right, what else can you do? OWASP dependency track has been around for a long time. So you want some kind of thing that's not Excel to track your dependencies? There's that, and it's free. There's also open source management platforms like ActiveState and others that you can pay for that do a little bit more than that, but you know, you could do the first one. And there's Open Policy Agent. So I talked about like, hey, setting these kind of standards and targets. How do you know if you're hitting those targets? Do you have to like manually check? That sounds super annoying, right? Open Policy Agent, it requires configuration. So if you have somebody who likes to write like XML or whatever, put them on that. They'll write some XML rules. They can run it against your stuff and it'll come back and be like, hey, this policy is not being followed. So you could just have this like automatically run once a deployment, once a week, you know, whatever makes you happy. And it'll tell you like, hey, this project isn't following internal policy. Maybe go take a look at it so that you aren't having to spend the time looking at things that don't need to be looked at necessarily. Also, vulnerability disclosure programs. I wasn't sure where to put this. These are not bug bounties. So if you're not familiar with the difference, having a thing that your lawyers write that say, this is where the bounds of our software are, and you are allowed to responsibly disclose something, please don't take down production, et cetera, et cetera. There's actually widgets out there to help you write these and help you talk to your lawyers about these. And you don't have to give them anything. You can just be like, here's a security.txt, here's our policy, here's the email address to send things to. You could be nice and be like, we will recognize you on a page, we will send you some stickers or a t-shirt or whatever. But you don't have to pay them. So if the company's like, we don't have the money for that, free. I mean, you do have to spend somebody's time to look at them. You will get some very entertaining things definitely done by ChatGPT. But you can usually figure out that was ChatGPT and just ignore those. Anyway, that is awesome, and you should do that. Bug bounty, you pay people money. If you have some extra money to burn, sure, do a bug bounty. Everybody loves a bug bounty. All right, but you want to go above and beyond. You don't just want to have an inventory. You don't just want to assess the risks associated with that inventory. You want to be like, this system over here needs to be secure. And maybe it's because you're following the EU's Cyber Resilience Act. Maybe it's because you're following the National Institute of Standards and Technology's Secure Software Development Framework. Maybe you have looked at the Canadian Centre for Cybersecurity, ITSM 10071, which is actually really interesting and short, like very readable. Recommend reading. Anyway, go ahead, build things from source yourself. If you're like, that's impossible or silly, I will tell you there are a lot of companies out there doing that. So if you really want to know what you are using, pull down the source, scan it, run it yourself, just like it's your own code. Take responsibility as if it's your own code. You will not be alone, but you totally need somebody who like is going to babysit this, because again, it's a puppy and it might pee on the rug. Scan the, I already said that, and then participate in the community. You find a bug, patch it upstream. All right, how can you help everyone? Don't have the time? Maybe just throw money at people. There's foundations out there, there's working groups out there, there's maintainers out there, and they could use funds. Throw money if you've got it. Join a working group. There's some of the Open Source Software Foundation, there's other ones where they are working on particular problems. So is there an area where you have expertise where you could weigh in and provide value? In some cases, I don't care if you're, in fact, if you are a technical writer with security knowledge, get on a working group and help write. You don't have to be a coder. You can totally help out by doing stuff like that. Like there's tons of stuff. They need people to help update the websites. Like they need people to do little graphics. Like get involved, help out. Whenever you start a new project, do secure by design. And also collaborative information sharing. I do not know if there's anything here. Fingers crossed there is. But there's the Alberta Security Community of Interest where people can kind of like compare notes. It's like public, private, all sorts of people get together. I'm not sure if there's like an NDA situation, but it's like a friend DA or beer NDA situation. And it's definitely handy to be able to share, like, here's what we're seeing. Are you seeing that too? Hey, cool, how did you solve it? And find better ways to solve the problems. All right, I am not doing a live demo. These are little pictures because demos and live is bad. All right, so let's say you were told PyYAML can't be used unless it is the latest version because something terrible happened. I have no idea what it is, but this is a made up example. Don't go home and rip out PyYAML. And report any use of the wheel affected by that vulnerability. All right. So if you have that inventory, you can be like, hey, what containers do I have? And what is on there? What are the vulnerabilities, dependencies, licenses in that container? And then search for it. I just took that scary request, and I was able to answer it by searching through something. Whether this is Excel, whether this is open source, whether you paid somebody for this, like that's ideally where you want to be, right? Log4j, how easy would that have been if you could have just typed in log4j version whatever? All right, this is only part of your problem though. Is everybody using the latest head commit? Can you tell what everybody's using? Depending on the tooling you have, you may absolutely be able to tell. So you're going to be able to tell, like, hey, Pete, this one's from 28 days ago. Maybe Pete's on paternity leave. And that's totally fine, because when he comes back, he's going to update. But I should at least be able to check and be like, how out of date are the systems that I have? Because even if your latest commit for everything is golden and follows the rules, is there something hiding under a desk somewhere that isn't? So remember how I said SBOM at every point along the way? You need to know what you've got where, because what if, and I mean, maybe it still could be valid that Pete's got the 28 days ago copy because somebody is running an exe from last month's release and was reporting a bug and he was trying to replicate the bug. So that's still a valid use case and he's allowed to do that. But you still want to know, like, where is that in my environment? And then you want to be able to do reports. And I have no idea why these images are not centered. They were centered. Anyway, so ideally, people who like GraphQL, there's like tons of a million different tools out there, but then put all that in so you can like create a pretty report and hand it to people in like PDF form or HTML form, because inside security, we love exchanging CSVs. If you hand that to not a technology person, they're not going to be thrilled with you. So just like color coding. Color coding good, but also remember to include things beyond just color, like unauthorized or limited, because some people are colorblind. So do multiple things. Anyway, so we're going to recap. Know what you have, where it is, be aware of the different risks, and de-risk. You said risk. Inventory, vulnerability, access, attacker, or something like that. I was taking notes on my phone. And then do a tabletop. What are we relying on? What happens if it goes away? And why are you in business? They're not going to let you do a thing if you're like, I want to take away this thing. And it's like, but that's what makes us money. So keep these in consideration. Also, TJ said, third-party risk is unavoidable. I agree. You can't DIY everything. You do not have the time and money. Or maybe you do. And if you do, like, come give me some. It is not a if, but a when you will have an issue. But the incident doesn't need to become a breach. I really liked that call out. If you're able to find something early enough before they get to the crown jewels, you have prevented the PII getting exposed or whatever. So like, plan for defense in depth. And the more suppliers you have, the larger the attack surface. I'm going to say the more open source you have, the larger the attack surface. That's not necessarily bad. It just means you have to threat model that, and you have to inventory, assess, and monitor. So it's the exact same thing as your third-party suppliers, except you can't ask for a security assessment. You kind of have to do it yourself. All right, Q&A time. There is no questions.
How would you overlay what you've presented here with, say, the polyfill situation that happened earlier this year?
Oh, God. See, here's a fun fact that I don't think you mentioned. I black out when I talk on stage, so like I can do everything I rehearsed, but I can't necessarily like on the spot unless I've rehearsed it. So maybe talk to me after. Anybody have a question I may have already rehearsed, since I black out while talking? All right. All right, awesome. Thank you so much.